All right, today we're going to look at some properties of logarithms. There are three properties that we're going to talk about today. The first one is the product rule, which just states if you take the log base b of x times y, it's going to simplify or expand into log base b of x plus log base b of y. And if you think back to our exponent rules, if I did b raised to the x power times b raised to the y power, the way that we simplified that was x plus y. So think about these properties of exponents to kind of get back to what you're used to or something you've seen before if you haven't seen these properties of exponents before. Quotient rule works the same way, so I got x divided by y, and then that becomes the log base b of x minus the log base b of y, and that's related to this b to the x power. So remember that our the logarithms are the inverse of an exponent, so that's why these things are all related. And then the last one is our power rule. So if we have an exponent on a variable or a number, whatever it is, what we're allowed to do is this exponent moves out in front of our variable and we multiply by it. So it's very similar to if I have a power raised to a power, it just becomes multiplication. So same thing. All of these things are related to exponent rules. So let's do some examples. So first thing we want to do is, if it says expand, what we want to do is we want to make them bigger. So you're taking that first rule and you're expanding it. So think about here, we've got 5 times 11. So remember, if we have multiplication, it becomes addition whenever we expand it. So the way that we would write this is we'd write the log, make sure you pay attention to what base you have, plus log base 4. So they would have the same bases as we added. So that would be the expanded version of this. And then if you wanted to, you could find both of those and add them together if you wanted to. But we're just expanding them. We don't have to simplify in the way that these problems are written. So same thing here, we got division. So remember, division becomes subtraction. So it'd be the log base 6 of 4 minus the log base 6 of 7. And then our last one, we're using our power rule. We got a 7 out here. We just move it out front. So it'd be 7 times the log of 2. Now, one thing I do want to point out here for this one, it just says log. So whenever it just says log, it's implied that it is a base 10. All right, let's do a little more complicated ones where they include all of them. So we got to kind of do them step by step. So the first thing we would do is, if you notice up here, we got multiplication between these two. So multiplication, remember, that becomes addition. So we're going to have the log base 7 of a to the 5th power plus log base 7 of b to the 2nd power. And then we divide it by c. So remember, division becomes subtraction. So we do subtract log base 7 of c. But we still have these exponents. So what we want to do is simplify those. So remember, we have our power rule. So the 5 would just move out front. So we have 5 log base 7 of a plus 2 log base 7 of b minus log base 7 of c. So that would be our fully expanded form for this logarithm. All right, so down here I wanted to introduce this. Anytime you see ln, that stands for the natural log. Natural log is basically just the log with a base of e. And e is kind of like pi. It's an irrational number. It's like 2.72 or 1, something around in there. But if you want to look up more of it, you can look up e and it'll give you the exact number of what it is. But basically just think of it as a number. So if you see ln, it works the same way that it does for all the logs. All the properties still apply, all the same. It just stands for natural log. Also, we have this 5th root here. So whenever you have a 5th root, what happens, let's say we have y and we take the 5th root of it. That's the same as taking y and raising it to the 1/5 power. So we just have a little bit of extra stuff just to deal with here. So if I want to expand this, so first thing I would do, we just write ln. So ln, we got x to the fourth. And then I'm dividing, so this becomes gonna become subtraction. So natural log of the fifth root of y to the third. All right, and then we have to use our power rule. So the 4 moves out front. And then over here, so I'm gonna kind of do it in two parts. So remember we said that if it was a fifth root, it becomes 1/5. So I'm gonna do minus 1/5. And then natural log of y to the third power. And then, so if we notice here, we have an exponent here. So now what we want to do is multiply both sides again. So we have 4 natural log of x minus, I'm multiplying 3, so it's going to be 3/5 natural log of y. And so that's the way that that one looks. So now we can also do the opposite of that. So now we can condense. So if we have the expanded form, what we want to do is then reduce it. So we do this 2 becomes our exponent, and then we have minus, so that becomes subtraction. Remember, we have log, so it's just 10 here. And just ignore my dog scratching at the door. I'll let her in a second. So x squared, and then the minus is over y. So that would be our condensed version. So think of it as the opposite of what we did earlier. All right, here we've got 4 log base 3 of a plus 3 log base 3 of b. So what we want to do, we got a plus, so that means we're multiplying. We've got these numbers out front, so they move to our exponent. So we got log base 3 of, that would be a to the fourth. And then we got plus, so we're just multiplying, so times b to the third power. So that would be our condensed version of that. Then we got one more example problem. So this one we got a little bit of stuff to deal with. So we've got a 2/3 out here. So remember, we can rewrite that as like that denominator would make it a cube root, but then just like we did with that 3/5 earlier, we're gonna kind of undo that. So it'd be, we'd have a cube root, and then we'd have a square inside the cube root. We also have this. So one thing to notice here, we've got this minus. The minus applies whenever we have two logarithms, but here, if it's just between these two, like number and a variable, we're gonna leave that together. So we don't wanna divide these. They're not gonna become division. It's only division if we have the log, if we're subtracting two logarithms. All right, so first thing we're gonna do is, I'm gonna rewrite this as log base 2, 3 minus x, and I'm just gonna move that 2/3 to our exponent. And then minus log base 2 of y. So we got this subtraction. I'm gonna then make it division, so make it 1 logarithm. So we've got 3 minus x to the 2/3 over y. And then I'm gonna do one more step, so I'm gonna change this into its cube root form. So it's gonna be the log base 2, so it'd be the cube root of 3 minus x squared. So remember, the numerator becomes r squared, and then we divide it by y. So that would be our condensed version of the logarithm.